So we ended up with this shape, which was an isosceles trapezoid y. Well, first of all, it looks like a trapezoid, and we were given these two angles that are the same. And we immediately concluded that the sides across from them are also the same, similar to a triangle. Okay, it works the same way. And we were asked to find AC, so it's just the same as BD here. So we got that figured out. Then they asked us for angle A, and I remember that these two angles, as well as these two, on any quadrilateral always add up to 180. Okay, the quadrilaterals we are studying, that is. Okay, it's because of the parallel lines here that is true. And so we found this angle just by going 180 minus 60 to get that, and this has to be the same since this is 60 here. Okay, so we figured that on Thursday. Okay, now we're going to talk about the kite here. So what is it asking us for? Find, when it's two letters, it's just a segment between them. Okay, WX. So they want this side right here. They want angle XYZ. This is angle, so it's X, Y, Z. So they're asking us for this angle right here. It's always the middle letter you have to kind of, that's where the main angle is going to be. Okay, it's going to be right here. And then it's asking what is the sum of WXY. So this is WXY and angle YZW. YZW. Okay, so they want the sum of these two. And we're going to talk about that. Let's not do everything at the same time. So we're going to do this first, okay? WX. And in this case, we know something about, we know that this is a kite. Shape is a kite. There's a couple things that we know that. If you go back to page where we took all those notes, 190 or so, I told you the properties of all the shapes. The diagonals cross at a 90, right? And you know that these two are the same. We can also conclude that these two are the same because there will be two pairs of congruent sides, of equal sides. So this is just, this one is the same as this one, and this one is the same as that one. Okay. Should have probably used a different color. Okay, because we're adding this. This is the same as this. This is the same as that. Okay, so this would just be 2 centimeters, and then we're done. So no big deal there. We figured that out. And then XYZ, right, is this angle right here, and actually in a kite, these are the only two angles that are going to be exactly the same. So angle XYZ is going to be 101 degrees. Done. Okay. And why do you have to use 3-letter notation, you may ask? Like, why can't I just say Y? Because around Y, there are two angles. There's the small one here, and there's the small one here. So you can't just say Y. If you say X, Y, Z, now you're referring to the whole thing, okay? And the sum of these two angles. What is the sum of them? Well, sum would be these two. What would these two add up to? Well, what do we know about all 4 angles in a quadrilaterals? I told you that on, I'm going to go find out exactly what page because I need to know. 190. On 190, I told you that the following is always true. It's always 360 altogether. So if we take 360 and we subtract this one, which is 101, and we subtract the other one here, which is 101, then what is left, right, is what these two should add up to. Okay, we don't know what exactly their measures are, but we could figure out what the sum is. So it's 360 minus 202. which is 158 degrees, is the sum of the two ends, basically the top and the bottom, because we've taken away the two that we know, so these two should add up to 158. Okay, that's as simple as that. And most questions are going to be like that. Keep in mind we can use trig to figure things out, and we will do that when we need to. But for now, just keep in mind that a lot of it is just going to be going grabbing to see if you know the properties of the different shapes. So on 194, I want you to copy, there's some blank space there on page 194, and just write this down as you see it, okay? Classify the following quadrilaterals, and I also want you to state two properties of each. This is on page 194. I should have 3 more. I don't know. Ruel, I don't see yours yet. Aiden, I'm not sure if you were here today. Grant, did you submit yours? Okay. You just have the paper copy? Okay. Yeah, for now, I'll just leave it. Normally, I want you to upload it still, so it's all in one spot. Okay. So you either have this on your study sheet or you need to memorize, but you should be able to name things, name the different shapes, like have a specific name for each quadrilateral as well as the triangles. Okay, so if you look at the first one, you look for unique features, right? So first of all, this is slanted. Okay, that's something like, okay, so now you're down to either a parallelogram or a rhombus, right? They're slanted. And we know that all 4 sides are the same. So, right, if I wrote down, right, all 4 equal sides or something like that. 4 equal sides. And I have 2 pairs of parallel sides, right? This is parallel to that. So 2 pairs of parallel sides. That is enough for you to say that it's therefore. This is the symbol for therefore in math, by the way, 3 dots forming a triangle. It's a rhombus. Okay. Parallelogram, if you said parallelogram, you're actually not wrong. It's technically still a parallelogram, but it's not specific enough. So I would still mark it wrong because you have to be as specific as possible. Okay. Right down to the subcategory. Next, this one has, right, 1 pair parallel sides. It has 2 right angles. Therefore, it's a right trapezoid. It's not an isosceles trapezoid, it's a right trapezoid. And how did I know that it has 2 right angles? Well, remember these always add up to 180 because of the parallel sides. So 90 and 90, it's 2. Okay. Next, you have 2 pairs of equal sides. And I'm basically just reading off of the diagram. What do we call the lines that go across from one corner to another? We call those diagonals, right? Diagonals meet at a 90. They meet at a 90. So this is a kite. Therefore, kite, trapezoid, rhombus. So sometimes you'll be asked to actually sketch, right? Sketch a rhombus or sketch a right trapezoid or sketch a parallelogram. And you have to label at least 2 or 3 things that are true about it. Label it on the diagram. So you need to be able to do that as well. So we're going to do that in a bit. Okay. Here, if you've written this down, I will ask you to scratch out 3, like the writing for 3, just scratch it out. You don't need to use a protractor or anything like that. Again, I'm using this as a backbone, right? So I'm going to ask you to add some diagrams. So we're still doing the same thing as we did up above this question that we just scratched out. So I'm just going to turn this into D and add the markings that I've done. I've added these markings, okay? Make sure you add that to your diagram. There's a tick here and a tick here, and these two have double ticks like that. And I'm also now adding one more thing that I forgot to do earlier. So state 2 things that you know about the shape and then name it. Call it what it is. And if you need to go to 190 to do that, always feel free to do that. What would you call D? What would you call E? Basically, just answer it in your head or try to look it up or whatever. But I'm going to go over it because there are some questions that I want you to practice on. So look, right? This is one pair of parallel sides and another pair of parallel sides stated. So you have two pairs of parallel sides. That's actually the parallel symbol in math, okay? Then I notice also that this tells me that these two measure the same and these two measure the same. So two pairs of equal sides. And that's all I can see from here. However, we know that this is a parallelogram because it's slanted. It's not a rhombus. Rhombus would have to have all four sides the same. Okay, so this is a parallelogram. What else do I know about a parallelogram? Now that you know that it is one, there's a number of things that you can still add to this. We know that opposite angles are equal, so this one is going to be equal to this one. We know that this one, I'm going to do two semicircles like that, is the same as this one, measures the same as that one. Right? So I could keep adding and adding things that are true about this shape. Use a blue pen to say that the diagonals they cut each other in half. So this is the same as this is the same as that, right? But they don't meet at a 90 here, okay? And so the list goes on and on. Some of these things are intuitive. Some of these things you might have to look up on your on page 190. Okay. Next, we have that base angles are the same. Or equal or congruent, right? I need you to know that word, congruent. It's the same thing as equal. And you have one pair of equal or congruent sides. Therefore, this is an isosceles trapezoid. Next, you have a rectangle, right? You should recognize all 90s, but we don't have all four sides being the same, in which case it would be a square. Now it's a rectangle, right? So you have two pairs of equal sides, two pairs of parallel sides, and you can also say four right angles if you want. Okay. At the top here, by the way, you could have still mentioned that it's one pair of parallel sides, no problem, but I'm only asking you to state two things, right? Therefore, rectangle. And I know you know the names oftentimes without the properties. But technically, without the fact that all four are right angles, this could technically be a parallelogram, okay? So you want to be as specific as possible here. It's pretty dry stuff, I know. You want to do some math, right? Give me math, I will solve it. But For some of you, this might be an advantage, right? You can just have this on your study sheet and go for it. Now, we're going to go skip a bunch of pages. And I'm going to get you to go to page 200. I'm going to ask you to go all the way to 202. So go to page 200. Oops. 202 now. Okay. Notice that they're asking you just to solve for the indicated length, side length, right, or angle, and to identify, right, or classify, right, same thing, the type of quadrilateral you're looking at. Okay, so there are a number of things that you can do to come up with that. And oftentimes there's very little math involved. There's just looking at the shape and predicting what it's going to be. Okay, so that's your task right now. Just stay online for now, okay? If you're here. So you should be able to see it, make markings on it. And if you've missed the marks online, they're also posted here.